Picture a massive, highly secured building.
Right.
You have guards at the front door, you have cameras everywhere, and, motion sensors in all the hallways.
Sounds pretty impenetrable.
Exactly. You think the building is totally safe. But then, a highly trained lockpicker sneaks up.
Okay.
And this lockpicker, they do not actually want to steal anything themselves. They just knock out the security guards, they break the lock on the front door, and they just prop it wide open.
Just leaves it open.
Right, and then they quietly slip away. So a few hours later, opportunistic thieves just happen to walk by.
And they see the open door.
Yeah, they see the open door, they see the sleeping guards, and they walk right in and completely destroy the entire building.
Wow.
So the lockpicker did not cause the major destruction directly, but, they are entirely responsible for making it possible.
That is such a perfect analogy, because that mechanism, the opening of the door, that is exactly what we see with one of the most devastating threats in global agriculture today.
It really is a perfect storm of biology.
It absolutely is.
Welcome to today's deep dive, everyone. We are tracking down a specific virus today, and it acts exactly like that lockpicker.
It causes massive economic damage.
Yeah, it ruins businesses, and it creates this terrible cascade of illness. So we are digging into the world of poultry science today.
We are looking at aMPV, right?
Yes, Avian Metapneumovirus. We are piecing together information from veterinary guidelines, agricultural studies, and vaccine manuals.
To really figure out how this virus breaks the defenses.
Exactly, and how the industry fights back.
Right.
Now, I want to speak directly to you, our listener, for a second.
Right.
Whether you are managing a commercial facility yourself or you are a beginner learning professional poultry vocabulary and practicing shadowing, this is for you.
We are breaking this down very clearly.
We are. We will use short, simple sentences. We will speak at a moderately slow pace, and we will leave brief pauses after important terms so you can mentally shadow or repeat the words.
It is going to be a highly focused conversation.
So let's just jump right in. Avian Metapneumovirus is a fascinating enemy.
It really is. To understand it, we first have to look at its structure.
Okay, what are we dealing with?
Well, it is an RNA virus. That means its genetic core is made of ribonucleic acid.
Okay.
And it belongs to a broader family of viruses known as the Paramyxoviridae.
Paramyxoviridae, that is quite a name.
Yeah, it is a big family of respiratory pathogens.
Speaking of that, let's ground this in reality and introduce our first shadowing vocabulary word.
Good idea.
The word is pathogen.
Pathogen.
A pathogen is a germ or virus that causes disease.
Right.
I will say it again. Pathogen.
Yeah, a very common word in veterinary science.
And here's a practical example. Avian Metapneumovirus is a dangerous pathogen.
Excellent.
So when this specific pathogen, aMPV, enters the environment, it has a very specific target, right?
It does. It heads straight for the epithelial cells.
Epithelial cells.
Yeah, those are the cells that literally line the surfaces of the body.
Like the skin or the inside of the throat?
Exactly. More specifically, aMPV has this strong tissue tropism.
Tissue tropism, what does that mean?
It means it has a biological attraction. It prefers a specific area. And its favorite area is the epithelial cells of the upper respiratory tract.
Okay, let's pause there for our second vocabulary word. The term is respiratory tract.
Respiratory tract.
The respiratory tract is the breathing system of the body, including the nose and lungs.
Right, the whole system.
I will say it again. Respiratory tract.
And the virus loves to attack this area.
Here is a practical example. The virus attacks the bird's respiratory tract.
Spot on. So this virus, it targets the upper portion of that tract.
Yeah.
Mainly the nose and the top of the throat.
How does it actually get into the body, though?
Well, think about a commercial barn.
Okay.
You have tens of thousands of birds living in very close quarters.
Right, they're packed in.
So the spread is incredibly rapid. It enters through two primary routes.
Sure.
The nasal route, so right through the nose,
Okay.
and the ocular route, directly into the eyes.
Just floating in the air.
Exactly. When one infected bird sneezes, it expels these microscopic water droplets into the air.
Oh, wow. So a neighboring bird just breathes in that droplet.
Yeah, or the droplet just lands right on their eye.
That is so fast.
It is. And once it touches the mucous membranes of the nose or the eyes, the virus binds to those epithelial cells and just begins its work.
Let's consider the scale of this for a moment. And this brings us to our third vocabulary word. The word is flock.
Flock.
A flock is a group of birds living together.
Very important term for farming.
I will say it again. Flock.
right?
And here's a practical example. The farmer checks the flock every morning.
So in commercial poultry farming, a flock is not just 10 birds in a backyard,
No, we are talking about massive populations.
sharing the exact same airspace.
So the virus has endless opportunities to find a new host.
Endless.
But I have to push back a little here.
Sure.
If it is just in the nose and throat, is it basically just a bird cold?
Well, technically, yes.
Then why is a simple virus in the nose such a big deal for the farmer? A common cold does not wipe out a whole business.
That is the big misconception. The virus by itself only causes a very mild disease.
Really?
Yeah. If you take a bird and you put it in a perfectly sterile, incredibly clean laboratory environment,
Okay.
and you infect it with aMPV, that bird will just get a runny nose.
Just a runny nose.
It'll sneeze, it'll have a little clear fluid around its eyes, and then it will likely just recover.
So the virus does not actually kill the bird directly.
No, it rarely does.
Then why the massive agricultural studies? Why the veterinary panic over this?
Because of the lockpicker analogy we used earlier.
Ah, right.
The real danger lies in what the virus destroys along the way.
What does it destroy?
It ruins the mechanical barrier of the respiratory tract. It breaks the lock on the front door.
How exactly does it break the lock? Can we look at the mechanics of the respiratory tract for a second?
Definitely. Inside the nasal passages and the windpipe, those epithelial cells we talked about,
Yeah.
they are covered in these tiny, microscopic, hair-like structures.
And this is our next vocabulary word. Our fourth word is cilia.
Cilia.
Cilia are tiny hairs inside the breathing tubes that sweep away dirt.
They act exactly like little brooms.
I will say it again. Cilia.
Very important little structures.
Let's use it in a sentence. Healthy cilia sweep dirt away from the lungs.
And that is exactly what they do. Healthy cilia are constantly moving.
Just constantly sweeping.
Yeah, they beat back and forth in this coordinated wave-like motion.
Wow.
Their entire job is to sweep dirt, dust, and bad germs out of the lungs and throat.
They push everything up and away.
Right, up and away from the vulnerable lower respiratory system. They literally are the security guards at the front door.
And the aMPV virus targets them specifically.
It does. When the virus enters, it invades the very cells that hold the cilia.
Oh, no.
Yeah. The virus takes over the cell's machinery to multiply. It creates thousands of copies of itself.
And what happens to the cell?
In doing that, it completely destroys the cell. The tiny hairs literally fall off.
So the sweeping motion just stops.
It completely stops. This physical breakdown is called ciliostasis.
Ciliostasis.
Right. The respiratory tract loses its physical ability to clean itself.
So all the dirt, all the dust, all the floating bacteria in the barn, it just sits there.
Exactly. The mechanical barrier is gone. The door is propped wide open.
And a commercial farm environment is full of bacteria, right?
Oh, absolutely. No matter how clean a farm is, it is full of environmental bacteria.
I live in the litter on the floor. They float in the dust.
So normally those healthy cilia keep them all out, but without the cilia, the bird is totally defenseless.
Which leads us to our fifth vocabulary word. The term is secondary infection.
Secondary infection.
A secondary infection is a new illness caused by bacteria after a virus weakens the body.
Right. The virus is the primary, the bacteria is the secondary.
I will say it again. Secondary infection.
This is where the real damage happens.
Let's use our practical example. E. coli caused a severe secondary infection in the flock.
Exactly. The virus does the early work, the lock picking, and the bacteria do the heavy destruction.
So who are these bacterial thieves walking past the open door?
Well, the sources highlight two opportunistic bacteria that are really notorious for this.
Okay, what are they?
The first is Escherichia coli, which most people just know as E. coli.
Right, E. coli.
And the second one is called Ornithobacterium rhinotracheae.
That is a mouthful.
It is. But both of them are just waiting for that open door. They enter the compromised respiratory tract, and they multiply aggressively.
This combination, the viral lockpicker and these bacterial thieves, it creates a very specific disease profile on the farm, doesn't it?
It creates a violent, really devastating condition.
What is it called?
Well, in chickens, this perfect storm is called swollen head syndrome, or SHS.
Swollen head syndrome. That sounds terrible.
It is, and in turkeys, which are actually even more sensitive to this virus, a nearly identical condition is called turkey rhinotracheitis, or TRT. Okay, the disease in turkeys progresses with incredible severity.
So let's trace the timeline on a real farm.
Okay, let's do it.
A farm manager walks into the barn. What do they actually see? How do these clinical symptoms evolve day by day?
The symptoms shift very distinctly. They move from a viral profile to a bacterial one.
Okay, so the first few days.
In the first few days, you just see the viral phase, the bird starts sneezing.
Right, the mild cold.
Yeah, you notice a clear nasal discharge, just a runny nose with clear fluid.
Okay.
You will also see these tiny frothy bubbles in the corners of their eyes.
Like a mild allergy or irritation.
Exactly. It doesn't look that bad at first.
But because those cilia are dying, that secondary infection is setting in right behind it.
Right.
How does their physical appearance change when those bacteria take over?
It becomes dramatic very fast.
Really?
Yeah, that clear liquid from the nose, it turns thick, opaque, and really sticky.
Oh, wow.
And the tissues surrounding the eyes begin to swell up.
Why does it swell so much?
Because the body is desperately trying to fight off these multiplying bacteria, and it responds with severe localized inflammation.
And this brings us to our sixth vocabulary word. The word is exudate.
Exudate.
Exudate is fluid or pus that comes out during an infection.
It is a sign of intense inflammation.
I will say it again, exudate.
Yeah.
Here is the example sentence. The vet noticed sticky exudate around the bird's eyes.
Correct. The body just floods the area with this exudate to fight the infection.
But the bacteria keep multiplying.
They do. So this exudate just builds up massively.
And that causes the swelling.
The swelling around the eyes spreads outward. It engulfs the entire head.
The whole head.
The whole head. It moves down to the wattles, too.
The wattles, those are the fleshy red flaps of skin under a chicken's beak, right?
Yes. The entire head becomes completely deformed.
What exactly is happening under the skin to cause that massive level of swelling?
Well, the bacteria actually invade the subcutaneous tissue,
Which is
the loose connective tissue right under the scalp. And as the body fights this losing battle, it produces a very specific protein during the severe inflammation.
And that specific protein is our seventh vocabulary word. The word is fibrin.
Fibrin.
Fibrin is a yellow protein that forms during severe inflammation.
It is part of the body's defense mechanism.
I will say it again, fibrin.
Right.
And the practical example, yellow fibrin was found under the skin of the swollen head.
Yeah. Now, normally, fibrin acts like a biological glue, right?
Right. It plays a role in clotting and tissue repair in humans, too.
Exactly. But in this massive bacterial infection, it just goes into overdrive.
How bad does it get?
If a veterinarian examines a bird that died from swollen head syndrome and they literally pull back the skin of the scalp, they will find a thick, yellow, jelly-like layer of fibrin just coating all the tissues.
That is horrific.
The medical term for it is fibrinous cellulitis. The entire head is encased in this infected fibrinous matrix.
Wow. Okay, so the sources mention another symptom here that seems, frankly, totally disconnected from a respiratory issue.
Which one?
They note that the birds become highly disoriented.
Right.
They have head tremors, shaking uncontrollably, and they develop something called torticollis.
Ah, yes. Torticollis.
Let's make that our eighth vocabulary word.
Okay.
The word is torticollis.
Torticollis.
Torticollis is a twisted or crooked neck caused by nerve pressure.
Very distinct visual symptom.
I will say it again, torticollis.
Yeah.
And the example. The sick bird had torticollis and could not walk straight.
Exactly.
But here is my question. If the virus and the bacteria are in the throat and the nose, why does the head swell up and why does the neck twist? That sounds like a neurological disease, not a respiratory one.
I know, it really looks neurological on the surface, which is why it can be so confusing for a farmer to diagnose at first.
So what is actually happening?
The mechanism is actually structural and mechanical. It all goes back to avian anatomy.
How so?
Birds have sinus cavities inside their skulls, just similar to humans.
Right.
But a bird's sinus passages are incredibly narrow and very intricate.
Very small spaces.
Very small. So when the bacteria cause that massive flood of exudate,
The pus.
right, the pus, the fluid has literally nowhere to go.
It just gets trapped?
It gets completely trapped inside those narrow, rigid bone cavities right beneath the eyes.
And just builds pressure.
Yes. But there is a crucial difference here. In birds, pus does not behave the way it does in mammals.
What do you mean? It isn't liquid.
No. Avian pus does not stay liquid. It lacks certain enzymes that keep it fluid.
Oh, wow. So what happens to it?
As it sits in the sinus cavity, it dries out. It becomes dense and very hard.
The sources describe it as being casein-like.
Yes.
Casein is the main protein in milk, right? The stuff that makes cheese solid.
Right. So the trapped exudate literally turns into a hard, solid yellow mass inside the face.
That is just awful.
And these solid masses take up physical space within the narrow skull. They create immense, unrelenting pressure.
Ah, I see. So it acts almost like a growing tumor pressing on the surrounding anatomy.
Precisely. That hard, cheese-like swelling presses inward against the inner ear.
And the inner ear controls balance.
Exactly. That is what causes the disorientation and the dizziness.
But what about the twisted neck?
Well, the mass also presses directly against the cranial nerves running through the skull.
Okay.
And when those nerves are compressed by that hard pus, they misfire.
And that misfiring nerve signals the neck muscles to spasm.
Yes. It pulls the neck into that twisted torticollis position.
So the twisting is just a mechanical consequence of pressure.
Right, from the hard pus. The bird is not experiencing a primary brain infection.
It is just severe localized pressure in the skull.
Yes. And because of that swelling and the pain and the twisted neck, the bird is completely unable to walk over to the feed lines or the water lines.
So they just starve.
They starve, or they die of dehydration. It is a terrible way to go.
Which brings us to the massive economic impact of all this.
The fallout is huge.
A commercial farm is a business. When a disease hits this hard, the ripple effects on production have to be immediate.
They are. How does aMPV impact the bottom line for a poultry producer? It is totally devastating.
Especially for certain types of flocks, right?
Particularly for laying hens and breeder flocks.
Laying hens are the ones producing the eggs sent to grocery stores.
Right. And breeder flocks produce the fertilized eggs, meant to hatch into the next generation of chicks.
So what happens during an outbreak?
Well, egg production just plummets. A farm can see a drop of anywhere from 5% to 30% in total egg output.
That is a massive loss of product.
It is.
But what about the eggs that do get laid? Are they normal?
No. And this reveals another really sinister capability of this virus.
What does it do?
The virus does not remain confined to the respiratory tract.
Wait, I thought it had tissue tropism for the respiratory tract.
It does initially, but in female birds, the virus actually enters the bloodstream and travels directly to the reproductive tract.
Oh, wow. So it moves down to the organs.
Yes, it causes severe inflammation in the ovary and the oviduct.
The organs responsible for forming the egg.
Exactly.
So the biological machinery that constructs the egg is actually damaged.
Severely damaged. Because the oviduct is so inflamed, it cannot properly deposit calcium to form the shell.
So what do the eggs look like?
The eggs that are laid are completely deformed.
In what way?
They lose their natural pigments, so they become very pale.
Okay.
The shells are incredibly thin or structurally fragile.
Like they would break in your hand.
Right. Sometimes the bird lays an egg with no hard shell at all.
Just a soft egg.
Just the soft inner membrane.
That must be a huge mess on a farm.
It is. These eggs break immediately on the conveyor belts, which causes further loss and massive cleanup issues.
And what happens in the breeder flocks? I mean, if the shell is compromised, the baby chick inside must be at risk.
It is at huge risk. And this brings in the concept of hatchability.
Which is our 9th vocabulary word. The word is hatchability.
Hatchability.
Hatchability is the percentage of eggs that successfully hatch into chicks.
This is the critical metric for a breeder farm.
I will say it again. Hatchability. Let's use it in a sentence. The disease caused a huge drop in hatchability.
Perfect. During an aMPV outbreak, the hatchability drops significantly.
By how much?
Often by 5% to 10%.
Why? Is the virus passing through the egg and infecting the embryo?
Interestingly, no. The primary cause of embryo death is physical, not viral.
Physical? You mean it goes back to the damaged eggshell?
Exactly. Think about how an embryo breathes inside an egg.
It pulls oxygen through the shell, right?
Yes, through microscopic pores in the calcium shell.
Okay.
When the oviduct is inflamed and the shell is formed improperly.
Meaning it's too thick or too thin.
Right, too thick in some spots, too thin in others, or lacking the correct pore structure entirely.
So the gas exchange fails.
Yes. The embryo literally suffocates inside the egg.
That is awful.
The structural defect of the shell cuts off their oxygen supply entirely. It is a secondary casualty of the virus.
There is another detail in the sources regarding the adult hens that sounds completely catastrophic.
Which one?
It involves the ovary itself.
Ah, yes. Egg peritonitis.
What is that?
Well, a laying hen has multiple follicles attached to her ovary at any given time.
Follicles being the developing yellow yolks?
Right. When the aMPV virus causes acute inflammation in the ovary, those delicate follicles can literally rupture internally.
The yolk breaks open inside the bird before it enters the oviduct.
Exactly. It spills directly into the bird's abdominal cavity.
Oh, no.
And the abdominal cavity is not designed to handle raw yolk.
I would imagine not.
It immediately triggers a massive, usually fatal infection that is known as egg peritonitis.
What happens to the hen?
The bird's abdomen fills with a toxic, cloudy fluid, and the hen dies rapidly.
So let's recap this nightmare for a second. A farmer is dealing with swollen heads, twisted necks, drops in production, fragile eggs, and sudden deaths from internal peritonitis.
It is a lot to handle all at once.
The natural response would be to find the cause immediately. But diagnosing this exact virus, aMPV, sounds like a total nightmare.
It is.
It sounds like chasing a ghost.
Chasing a ghost is honestly the most accurate way to describe the diagnostic challenge.
But why? I mean, the damage is so obvious. The swelling is right there on their faces.
It is all about the timeline.
Okay, break that down for me.
The farmer notices the problem when the heads swell up, right?
Right.
When the torticollis begins and when the eggs lose their shells.
Yeah, that's when it's obvious.
But remember, all of those severe symptoms are caused by the secondary bacterial infection.
Right, the E. coli.
The virus was just the lockpicker.
I see.
By the time the massive destruction is visible, the lockpicker is already gone.
Wait, how fast does the immune system clear the actual virus?
Very fast. The virus only replicates and remains in the respiratory tissues for about 6 to 7 days.
Just a week?
Just 1 week. After that, the bird's immune system successfully eradicates the aMPV virus from the body completely.
But by then, the cilia are already dead.
Exactly. The mechanical barrier is ruined.
So the bacteria take over and cause the swelling on, what, day 10 or day 12? So if a veterinarian comes in, takes a swab from a bird with a massively swollen head, and tests it for the aMPV virus.
The result will be completely negative.
Negative.
Completely negative. They will isolate massive amounts of E. coli from that swab, but they will find absolutely zero trace of the virus.
The ghost has literally left the scene of the crime.
Exactly.
So how do you prove it was ever there? How do you confirm the diagnosis if the virus is gone?
You basically have two distinct diagnostic pathways.
Okay, what is the first one?
The first requires impeccable timing. You have to catch the virus in the act.
How early?
The farm manager must notice the very first signs. The mild sneezing, the clear runny nose.
On day 1 or 2?
Yes. And the vet must immediately swab the choana.
The choana.
It is a little slit in the roof of the bird's mouth.
Okay. And what tests do they run on that early swab?
They run a PCR test.
Polymerase chain reaction.
Right. PCR does not look for bacteria.
No.
It amplifies and detects the specific genetic material, the RNA, of the virus itself.
So if you swab early enough, PCR will catch the lockpicker right there in the hallway.
Exactly.
But what if you are too late? What if the heads are already swollen and the virus is gone?
Then you transition to the second diagnostic pathway, looking for footprints.
Footprints.
You use serology.
Serology, that is testing the blood serum, right?
Yes, serology is the study of blood serum to detect antibodies.
Okay.
When a bird is infected with aMPV, its immune system produces specific antibodies designed to neutralize that exact virus.
And those antibodies stay around.
They remain circulating in the blood for months after the virus is destroyed.
So you just draw blood from a bird that has already recovered from the swollen head?
Yes. If the serology test shows high levels of aMPV antibodies, it provides definitive historical proof that the virus passed through that flock.
You just need that proof, I guess, because other diseases can cause similar swelling.
Right. Diseases like infectious coryza can cause similar facial swelling. You must know exactly what break the lock so you can prevent it next time.
So once a farm knows what they are dealing with, they have to look at their own practices.
Absolutely.
Because the sources are incredibly clear about one thing. The virus does not act alone.
No, it relies heavily on environmental stress.
The environment inside a commercial poultry house is basically the greatest variable in this whole equation.
It is. The disease explodes into a complete disaster when farm management fails to control the environment.
The sources mention high stocking density.
Right.
Putting way too many birds in one space, that causes psychological stress, which suppresses their immune system.
Yes.
And obviously it means the virus has a much shorter distance to travel between hosts.
Density is a major factor, but the air quality is the critical catalyst.
Air quality. And that leads us to our 10th vocabulary word. The word is ventilation.
Ventilation.
Ventilation is the system of moving fresh air into a building.
Super important on a farm.
I will say again, ventilation.
Yeah.
Let's use our example. Good ventilation removes toxic ammonia gas from the barn.
Perfect. Managing the air requires flawless ventilation.
Which is what? Exhaust fans.
It is an engineered system of massive exhaust fans and air inlets.
Yeah.
Designed to constantly pull fresh outside air into the building while extracting the stale, contaminated air.
What happens when the ventilation is inadequate? Like, what builds up in that stale air?
Well, think about bird waste.
Manure.
Manure and damp litter on the floor.
Huh.
It naturally decomposes.
Right.
And as it breaks down, it releases toxic gases. The most prominent and dangerous one is ammonia.
Ammonia.
Hydrogen sulfide is also produced.
Okay.
So if the ventilation fans are not running properly...
Or if the barn is sealed up tight during winter to save on heating costs?
Exactly. Ammonia gas builds up incredibly rapidly.
Ammonia has that really sharp, intense burning smell.
Right.
If a human walks into a barn and their eyes immediately start watering, the ammonia levels are already dangerously high.
Now think about what that toxic gas does to a bird that is breathing it constantly, 204/7.
It can't be good.
The ammonia gas actually acts identically to the virus.
Wait, in what way?
The ammonia chemically burns the epithelial cells in the respiratory tract.
It burns them.
Yes, it paralyzes and physically destroys the cilia.
Oh, wow. So bad air literally strips away the mechanical barrier before the virus even arrives.
Exactly. The chemical burn opens the door.
That is wild.
If aMPV enters a barn with poor ventilation and high ammonia, the virus doesn't even have to work hard.
Because the cilia are already damaged.
The defenses are already compromised, and the secondary bacteria are probably already multiplying.
So a poorly ventilated barn practically guarantees a severe outbreak of swollen head syndrome.
It does. It is a recipe for disaster.
This highlights the critical importance of defensive management.
Right.
Which brings us to our 11th vocabulary word. The word is biosecurity.
Biosecurity.
Biosecurity refers to strict rules to protect farms from disease.
It is the defensive wall of the farm.
I will say it again, biosecurity. And the example. Strict biosecurity prevents pathogens from entering the farm.
True biosecurity requires absolute discipline.
What do the guidelines say about it?
They emphasize strict resting periods between flocks.
What does a resting period look like?
When a flock of meat birds is harvested and the barn is completely emptied,
Yeah.
you cannot immediately bring in a new batch of chicks.
The barn has to just sit empty.
Yes. All the old litter must be removed, the floors and walls must be washed,
Okay.
and then the barn must remain completely empty for a minimum of 2 to 3 weeks.
Why so long?
Because pathogens, both the viruses and the bacteria, they need hosts to survive long-term.
Oh, I see.
The resting period breaks the biological cycle. It literally starves the pathogens out.
But what if a farm is currently in the middle of a massive outbreak?
That is a different situation.
The birds are already sick, the air is already full of bacteria. What biosecurity interventions happen while the birds are still inside the barn?
In that case, the sources detail the use of aerial disinfectants.
Aerial disinfectants,
Yeah.
like spraying the air.
Yes, to reduce the pathogen load in the environment.
How do they do that?
Farm workers will use specialized fogging equipment to spray a fine, airborne mist of chemical disinfectants directly into the air of the barn,
What kind of chemicals?
like a formal solution or an iodine-based spray.
Wait, they spray it while the birds are breathing the air?
Yes, they do.
Is that safe?
The mist is very carefully calibrated. It is just light enough to be safe for the birds to inhale in small amounts, but strong enough to kill the free-floating bacteria and viruses suspended in the dust.
Wow. That is an intense intervention.
During a severe outbreak, this might be done once or twice a day.
It just lowers the environmental pressure.
Exactly. Gives the birds' immune systems a fighting chance.
Okay, let's move to the actual medical intervention.
Right.
A farm manager is looking at a flock with swollen heads. Before they mix any medication, they have to rule out something far worse, right?
Yes, this is a critical step.
The sources dictate a very specific first check. You have to look at the dead bird's legs.
Right.
Why are we looking at the legs when the disease is clearly in the head?
Because of the differential diagnosis.
Okay.
Swollen heads can definitely be caused by aMPV, but they can also be the very first sign of a total nightmare scenario.
Which is?
Highly pathogenic avian influenza, or HPAI.
Bird flu.
Yes.
The virus that triggers international trade bans and massive culling.
Exactly. HPAI is a systemic, highly fatal virus that completely destroys blood vessels.
So what does that have to do with the legs?
A hallmark sign of HPAI is subcutaneous hemorrhaging on the unfeathered parts of the bird.
Uh-huh.
So if you look at the shanks, those scaly lower legs,
Yeah.
and you see dark purple widespread bleeding right under the skin, you stop immediately.
You don't try to treat it with antibiotics.
Absolutely not.
Yeah.
You exit the barn and you notify government veterinary authorities immediately.
Because it's too dangerous.
An HPI outbreak requires total quarantine and rapid depopulation to prevent a national agricultural crisis.
But if you check the legs and they look completely normal, no bleeding, just normal yellow scales,
Then you can proceed, assuming it is swollen head syndrome caused by aMPV and the secondary bacteria.
so how do you intervene medically at that point?
First, you separate the most severely affected birds.
The ones that can't walk because of the torticollis.
Exactly. You separate them to stop them from being trampled by the healthy birds.
Okay.
Then, you treat the entire flock via the drinking water lines.
Because you can't inject every single bird.
Right, it's thousands of birds. And remember, you're treating the symptoms and the secondary bacterial infection because the virus itself has no cure.
What medications are actually deployed in the water?
The sources recommend starting with antipyretics.
Fever reducers.
Yes. A drug like Paracetamol, which contains paracetamol, is added to the water to lower their body temperature and reduce pain.
Make them a little more comfortable.
Right. And simultaneously, they administer expectorants.
An expectorant is a medication that thins mucus, right? Making it easier to cough up and clear from the airways. Exactly.
A cold medicine for humans.
Very similar. The guidelines specifically name bromhexine.
Bromhexine.
Yes, bromhexine is run through the drinking water for 3 to 5 days.
What does it do?
It breaks down the thick, sticky mucus in the windpipe, which helps the birds breathe and prevents the lower airways from clogging up entirely.
That makes sense. But what about the hard, casein-like pus trapped in the sinuses? Does the expectorant melt that hard, cheese-like stuff?
It does not.
Oh.
Once that exudate solidifies into those hard yellow masses, medication in the water will not dissolve it.
So how do you get rid of it?
Removing it requires grueling manual labor.
Wait, the workers have to remove it physically?
Yes. For high-value birds, like breeders, workers must physically catch the birds one by one.
Oh my God.
They have to gently open the swollen tissues and manually squeeze or extract the hard pus masses from the sinuses and the eye sockets.
That sounds terrible for everyone involved.
It is, but it relieves the mechanical pressure on the nerves, so the torticollis stops.
And after they extract it, immediately after extraction, they apply antibiotic drops directly into the eye.
The sources mention Gendexa, right?
Yes, Gendexa. It combines an antibiotic and a steroid. It fights the local bacterial infection and reduces inflammation.
Wow! That is an incredibly labor-intensive reactive strategy.
Highly reactive.
I mean, treating the damage after the lock is completely broken is just a losing battle.
It is. The ultimate strategy must be proactive defense.
We have to stop the lockpicker from ever touching the door in the first place.
And that is achieved through a highly sophisticated two-part vaccination protocol.
Vaccination trains the immune system to recognize and destroy the pathogen before it can cause damage.
Exactly.
Which brings us to our final 12th vocabulary word.
All right.
The term is attenuated vaccine.
Attenuated vaccine.
An attenuated vaccine is a weakened live virus used to create immunity.
Very important medical tool.
I will say it again. Attenuated vaccine.
Yeah.
Let's use our final example. The young chicks received an attenuated vaccine as a spray.
So let's break that down. An attenuated vaccine uses a live virus that has been taken into a laboratory and deliberately weakened.
Right. It is still alive, so it can enter the cells and trigger an immune response, but it is too weak to actually destroy the cilia or cause ciliostasis?
Exactly. But aMPV requires a layered defense system.
Why?
Because the sources indicate the use of both live attenuated vaccines and inactivated or killed vaccines.
So 2 different types.
Yes, they're used at different times to build 2 different types of biological shield.
Walk me through that timeline. How is the first shield built?
The first shield must protect the front door.
The respiratory tract.
Right. The live attenuated vaccine is given to very young chicks, often within the first week of life.
How do they give it?
It is administered via a coarse spray over the flock, or dropped right into their drinking water.
So the live weakened virus goes exactly where the wild virus would naturally go.
Straight to the mucosal lining of the nose and throat.
Wow, it mimics the natural route of infection.
Yes, and this triggers mucosal immunity.
Mucosal immunity.
It trains the immune cells, specifically located in the respiratory tract. It places highly trained guards right at the front door to protect the cilia.
That is brilliant. But that local shield is not enough for a bird that will live for a whole year laying eggs, right?
No, it isn't.
Why do they need the killed vaccine later?
Because mucosal immunity can fade over time. And importantly, it does not protect the deep internal organs.
Like the reproductive tract we talked about.
Exactly. So before a pullet, which is a young hen, is moved into the laying barn to start producing eggs.
Yeah.
She receives an injection of an inactivated, killed aMPV vaccine.
An injection straight into the breast muscle, usually.
Right, and this injection completely bypasses the respiratory tract.
Where does it go?
It triggers a massive systemic immune response.
Yeah.
It floods the bloodstream with antibodies.
Okay.
This is called humoral immunity,
So it builds an internal shield.
a very vital one.
Right.
This systemic shield protects the reproductive tract. It guards the ovary and the oviduct.
So even if a wild virus somehow slips past the respiratory defenses months later,
The high levels of circulating antibodies in the blood will neutralize it before it can damage the eggshell machinery or cause that fatal peritonitis.
the live vaccine protects the ability to breathe, and the killed vaccine protects the ability to produce.
You really need both to survive.
It is a remarkable coordinated defense system designed to counter a perfectly coordinated biological attack.
It really is.
We have covered incredible ground today. We analyzed the RNA structure of the pathogen, tracked its invasion through the flock, and detailed the mechanical failure of the cilia in the respiratory tract.
We saw how that failure acts as a lockpicker,
Right.
allowing a catastrophic secondary infection to take hold, flooding the sinuses with exudate and fibrin.
Causing the pressure that leads to the twisted neck of torticollis.
Exactly.
We tracked the economic fallout, the plummeting hatchability, and the necessity of diagnosing the original ghost virus.
And we learned that fighting back requires the strict discipline of biosecurity
The engineering of clean ventilation.
and that dual-layered shield of an attenuated vaccine protocol.
It is a profound example of how seemingly small mechanical failures in biology open the door to massive systemic destruction.
It absolutely is.
Now, as promised, before we leave you, let's do a very brief shadowing recap of all 12 vocabulary terms we learned today. I will just say the word and you can repeat it.
Excellent practice.
Flock, respiratory tract, pathogen, cilia, secondary infection, exudate, fibrin, torticollis, hatchability, ventilation, biosecurity, attenuated vaccine. Great job.
Really good.
Which brings up a fascinating final thought for you to consider as we close today.
Oh, what is that?
Well, we spend so much time engineering vaccines to fight the virus and developing antibiotics to fight the secondary bacteria, right?
We do. A lot of time and money.
But if the entire disaster stems from the mechanical destruction of the cilia, the breaking of the door, what is the future of veterinary intervention?
That is an interesting question.
Will we eventually move beyond just killing pathogens and develop therapies that instantly regenerate damaged cilia?
Wow.
Imagine a biosynthetic aerosol that physically coats and protects the respiratory lining, acting as an artificial barrier while the bird heals naturally.
Like a temporary mechanical shield.
Exactly. If the real danger is the open door, perhaps the next great leap in science won't be a better weapon to fight the lockpicker, but a better temporary lock.
Something to think about for sure.
Thank you for joining us on this deep dive. Keep asking questions and keep exploring.